So I think that I am ready to start cutting. Going to go through this partly as a exercise for myself to make sure that I somewhat document what it is that I'm working on here, and also for, I guess, anybody interested. So the way this is what our final cut is going to look like. We have the neck pocket, the cavities for the two pickups. This is a representation of where the bridge is going. For the electronics cutout, one thing I'm doing is trying to have a minimal amount of wood removed, so these conform quite closely to the switches. I don't like having a large cavity here with just open air. This might bite me later on, but I'd much rather do precision wiring so that they go straight down these channels without any unnecessary wood being removed. Okay, so here's the cool part. If this isn't cool to begin with, here is a representation of the neck. So if I bring up the picture, here's what the neck looks like, and we have a curvature of the neck in the back here that fits into that slot. This depth is about an inch or so. We have a 9.5 radius fretboard and 20 frets, 34-inch guitar. So what I did is I took this stock here. You see it does taper to conform to a kind of your underside of your hand, but this part here is a constant height from the fretboard down to the bottom, and that's what is modeled here. So this neck here fits, it is modeled perfectly against the neck that I actually have. Now, if we come in here and look, one thing that I did, even to get that curvature on the end here, I took a picture of that neck from the top down and lined it up here, and then created a curve that perfectly fits that neck. And you can see the taper and everything. And the reason for this level of insanity is I was trying turn off some of this stuff here. The problem or the concern that I had was when I put the bridge in, there's some variability in the height adjustment this way and the depth adjustment this way. And what I wanted is, when viewed from the side, if you were to draw a string, and you can actually see this string right there, the one that's lit up blue right now, this string is representative of the low E string on the guitar. This point here is the depth that was measured at the nut without any filing. It's about, I don't know, it's about, doesn't matter. It's exactly what was measured. And then this bridge here was modeled against the actual bridge that we had. And while doing so, I determined essentially the optimal point that E string should attach to its point here. Now, it's centered in this model here. It's only centered here just to conform to the center of our geometry here, but it's actually going to be moved over. But when we do install this, this is, and I'm just double checking my own my own work here. This is essentially the point about 1/8 of an inch behind. So I can move the bridge plate back a little bit, and I can also move it forward. And I can move it up, and I can move it down. So this gives me about 1 millimeter travel up and 2 millimeters of travel down, as well as the ability to adjust the nut as well as the truss rod. But here's the kicker is I needed to know how deep do I cut this portion here? How deep does this neck fit inside of the cavity of the body? And so in doing all of this, according to Fender and everybody, at the 17th fret, and I'm going to have to double check it. Sorry, let me pull this back. At that 17th fret, this is, okay, this is representative of the crown of the fret. This distance here, which is 2.4 millimeters, that is, from what I've read, the recommended distance to have the relief distance at the 17th fret between the top of the crown and the bottom of the string. And this line is perfect, and it will sit in the bottom of the nut here. It sits on the very top of the bridge there. And one thing you can see is, there we go. We have a little bit of a gap here. From here to, sorry, I'm trying to click it. I can't click my string. Hold on, there we go. There to here. Right now, it's a little bit tall. It's at 0.258 millimeters. And this will give me the ability to move this up a little bit. It'll give me the ability to cut this down a little bit if needed. And I know when I cut the neck, it's going to be right a little bit high. But this gives us just a tiny, tiny bit of play. And this, after a little bit of trial and error and confirmation with these measurements here, will give me the optimal position for that neck, given the hardware that I have right now. This last one at the 20th fret, this is the top of the crown. So when you push the string down here, this line here now is representing the E string when it's pushed down at the 20th fret, and the purpose of this was to get the height of our pickup, and that is supposed to be 2 millimeters above. This box here is a 2 millimeter high box, so this is not actually going to be there. It's going to be air, but this is the gap at that string. So this should be where the pickups are going to be sitting, given this configuration. And you just kind of eyeball it to see, and you're like, okay, it rides up a little bit higher than the fretboard. This might be a little high. We'll have to adjust it, but I think if I've done all of my work right, this is the mathematically optimal position for the neck in this body, which will give us the most adjustment. We still have like 2 millimeters to move in almost every direction, so we have a lot of wiggle room to make this right. But anyway, here we are. So one other great thing with being able to model the neck this way is if I turn off the neck and look at this cavity here is a Boolean operation, which means that we took the neck here and we say, okay, we're going to start with it. Let me see if I can find that operation right here. So this is our operation before we did it. So we created the body with that, and we say, okay, where are we going to put the neck? And we position the neck exactly where we want it. and say, okay, that's where we're going to have it. Take this body, this orange body, this yellow body, and subtract the space that that occupies from the wood in here, and basically do a cut of it as if that were in place. And it does a great job. It does a perfect job. This will be a perfect fit for that neck. Now, once we cut it on the CNC machine might cut us a little bit shy, and we'll add some offset to make that fit. But again, we're trying to go at this in the absolute most optimal position, and I think we're ready to put a knife to the piece of wood and cut this bad boy out. So I need to make a run to the hardware store to pick up some stuff, and we're going to make some dust.